Inertia is the tendency for objects to continue their state of motion. Basically, objects just want to keep doing whatever they are doing. So, if we have a resting object, they want to stay at rest, which means that things don't just spontaneously move unless a force is applied. And moving objects want to stay moving. Things only change motion when a force makes them. But keep in mind when you watch these examples that friction opposes everything on Earth.
So let's say that Slush here is sitting on top of a car, which is a terrible idea, at a stoplight or whatever, and he gets rear-ended. What happened to Slush? Well, compared to the car, a person might say that he flew backwards. But upon further inspection, you will realize I had Slush lined up here with the space between the blinds back there. And so he did not go flying backwards. He stayed put, and the car actually went moving forward. And so because objects at rest want to stay at rest, when the car gets hit, the force is applied to the car and the car starts moving. But the objects inside of the car are not directly affected by that force. And so if the body of the object is not stuck in so that it moves with the entire car, then the car will move and the body will not. And moving separately from the car is where a lot of our damage occurs. So here we are, sitting at a stoplight, not moving. And when we start to accelerate the car, check out what the little bean guy does. There we go. We put seat backs with headrests in because back in the day they used to only have
Bench seats that were about as high as an average school chair with no headrests at all.
What would happen is that when the car moved forward because it got rear-ended or somebody accelerated too quickly, is that the person's head wanted to stay put. And that is a very dangerous situation because the neck is a terribly engineered body part as far as strength goes. So they put headrests into cars and airplanes and roller coasters, right? Because we want to make sure that the entire spine accelerates at the same time, speeds up and slows down together. So those headrests keep that head from staying put when the rest of the body moves forward.
So headrests help ensure that when a vehicle positively accelerates or speeds up, that the cargo or the person will positively accelerate along with it. This helps keeps the person's head safe. It helps keep the cargo moving. And if you're looking for a fun ride, a low back means it's going to have low acceleration or speed up slowly. High back means it's going to speed up really fast and have high positive acceleration.
So now Slush is driving along on his car here, and he is going to slam on the brakes incredibly fast. And what we're going to see happen is that when he slams on the brakes or he hits something very quickly, he and the car are accelerating together. But then what happened? Again, there's a tendency for people to say that in a car crash that somebody goes flying forward, but they don't go flying forward at all. The brakes or the crash that happens to the car itself, but again, the human body inside is a separate entity. And so both things are traveling at 40 miles an hour. The car negatively accelerates from 40 to 0, and the person's inertia wants to continue moving at 40 miles an hour. And so that person will continue moving until something happens, until it hits the windshield or goes flying out of the car and hits the pavement. Driving down the road, all forces balanced in the car. Uh-oh. Time to slam on the brakes. Unbalanced force. And Beanie wanted to continue in its state of motion. Did not fly forward, it was just moving, and the brakes didn't act on him. And so forward he goes, sad.
If a vehicle negatively accelerates or slows down due to a crash or brakes, that doesn't mean that the body wants to negatively accelerate or slow down without a force acting on it.
So the inertia controller that has been placed into cars, right, is the handy dandy seatbelt. And so when somebody is seatbelted into the car, now whatever force happens to the car happens to the person. And so if he goes and he slams into the brakes right? It stops his motion, his body mass, from moving forward. Now, that doesn't mean that a person doesn't lurch forward and the head lurches forward and the arms lurch forward, right? And so there is damage that can happen to people's necks during a car accident.
Seatbelts apply that unbalanced force to the person or the cargo to ensure that we slow down with our car. Rides without seatbelts slow down extremely slowly. Rides with seatbelts slow down a little bit more aggressively. Rides with bars slow down faster. And rides with complete harnesses have really crazy negative acceleration.
That if the deceleration happens too quickly, then the airbag goes to try to keep all of that mass and that inertia from continuing forward.
And airbags only deploy with extremely rapid negative acceleration.
Driving down the road, and we're gonna turn. Now, Beanie wanted to keep going straight. So when we turned left, he went right. But not because he just went right because it seemed like fun. It's that his inertia wanted to continue moving forward and we went
left. It's harder to accelerate, speed up, slow down, or turn a large dump truck because it has so much more inertia. Faster moving objects always have more inertia too, which makes them a lot harder to slow down, resulting in often a crash at the bottom.
Objects at rest want to stay at rest, objects in motion want to continue motion, and if you have two separate objects moving and one object gets a force that the other object doesn't get, that object either wants to not move or stay moving, and so we have to put inertia controllers in to keep all of the objects moving together at the same rate.